Hello, welcome. So I know that AI-powered filters and editing tools, when it comes to photography, have really started to take off. And Bending Spoons has had some great success this year with Rimini, which generates AI selfies and AI photography. So just to start, if you can share with us what you define AI photography as, and what are some of the real-world applications?
AI photography is, AI photographs are basically images, synthetic images that are generated by an AI model that looks like real photograph, right? So for example, a user through text can describe the content that they want to see, right, that they want to generate, and the model would generate a photograph that reflects that. The selfies, let's say, are an extension of the photograph where you can actually represent yourself. So in that case, for example, in Rimini, the user uploads some of the images, they capture some of their selfies. We fine-tune the model to learn, the appearance of the person, and then you can generate yourself in different poses, different, places. So that's what it is.
Would you like to add?
No, I mean, Federico already described pretty well. I mean, the point is, it's sometimes difficult to capture a really good shot with a camera. I mean, you need to have some maybe expensive gear, maybe you need some professional abilities, while if you're free to generate them with AI, you can capture the appearance of the person, and then you can generate high-quality pictures without the need of a professional, or, of course, they are imagined, but they look realistic for many use cases.
Yeah, back to the use cases, I think one of that we've seen for the AI selfies that is popular right now, for example, is the professional headshots. On LinkedIn, I've seen many. Another use case is for example, for stock, maybe more professional, but for example, the creation of stock images. So it's much easier now to create stock images. You don't have to have a set and lighting and stuff. You can just create, or product placement as well.
And from a technology point of view, what has changed recently in the last year or so that has enabled this to be possible?
There have been a few innovations. I mean, the thing that started it all was the release of Stable Diffusion. Many diffusion models had been trained before, but most remained private. And Stable Diffusion was the first large-scale diffusion model that was published open source, and people could innovate on that. And then, on top of that, many innovations have arisen. One of them, which allows much more artistic control over what you generate, is called ContourNet. Essentially, Stable Diffusion allows to generate images starting from text, but text is a modality that's not super precise if you want to have complete control over the image you generate, such as artists need to do. And so ContourNet allows to control what you generate based on other modalities, maybe reflecting a particular human pose or respecting some edges that you want to respect, or a depth map, and so on. This has changed a lot how Stable Diffusion was used. And the other big thing, especially in our field where we try to represent users, is there's a whole flurry of methods started with textual inversion and Dreamwidth that try to incorporate the appearance of a user that it's not known by the model at the beginning into what the model can generate. So the model is general purpose, but it's not trained, say, on me. But then I can fine-tune it in many, many different ways to represent realistic images of myself. This has also changed the panorama a lot of what you can do, because otherwise you could only generate stuff that's, general purpose, but not specific to yourself.
And what do you see as some of the main challenges of this area that you've come up against, or some of the constraints?
One of the challenges for sure that we're trying to address is the local editing, right? So we want to have control on the output, right, of the images that are generated on the style, on the pose, etc. This cannot be expressed just by text, right? And so one challenge for sure is to be able to just modify part of the images without changing the rest of it, the context. Because like there's also one thing where the models somehow learn biases from the data, right? So if I say, if I take a picture of myself and I say, change my hair to gray, it might shows up glasses, for example, eyeglasses, for example, because most of the images it has seen
or
right
wrinkles.
From the internet.
Or wrinkles.
Or wrinkles, yeah, exactly. So those kind of things, right? So yeah, this is one of the challenges, and I think there are others.
Yeah, in fact, there's been a lot of innovation in the space that Fede is talking about. So the idea is, with diffusion models, you can really use them not only to generate new images, but also to edit images. The point is that one disadvantage that diffusion models have with respect to traditional methods of generation is that you need many steps to generate a single image. But on the other hand, if you have like 50 steps to generate an image, you can really do stuff during all this time. You can guide the image towards certain objectives, and in particular, you can try to reproduce some parts of an existing image. And this allows diffusion models to be used for image editing. And they work really wonders in many cases. But the point is that it's not super reliable. So it's hard to find a single editing method that works reliably across many use cases. We've experimented with a few. Now we've seen the first model that try a mixture of expert techniques to use, different experts to edit, to do different kinds of edits to images. So editing pictures with respect to generating them is certainly one of the challenges.
Yeah.
Go ahead.
Well,
another challenge that we face, since we generate pictures of people, you want to make sure that the pictures that you generate really do resemble people, and you need some way to measure that. And it's not that easy, because all the metrics that you have to measure if two pictures resemble each other come from the world of facial recognition, which, they kind of work, but they are really meant and trained to distinguish between different people. So these metrics are able to say that Federico and me are different people, but when you start generating something that almost looks like me, but not quite, and you want to distinguish it from something that perfectly resembles me, it's very hard, because this metric is not very fine-grained. And so a bad model that would generate someone that almost looks like me, and a good model that generates something that is perfectly like me, are not easily distinguishable by this kind of metrics, and I've not seen any new metrics that capture these fine-grained distinctions, and which could also be used to guide the generation to have more perfect details, but there's not much in this space.
Did you have something to add?
No, I agree. Like, as Andrea was saying, identity preservation is one of the challenges that we see. Like, people is very, very sensitive to their appearance, right? They can detect, like, minor changes. And so if they want to post their picture on social media, that is generated by AI test to resemble them, like, truly.
So you want to embed it so that it's almost complementary, given whoever's appearance.
Yeah, exactly.
You mentioned bias, which is really interesting, because one thing I often think is the AI is only as good as the data that is being input. How do you address those kind of biases in data sets?
Well, it's not easy, because it's true that these models, these foundational models such as Stable Diffusion, incorporate lots of biases, and so it's hard to preserve the characteristic of the user. One way to do that is to slightly overfit on the particular user you're trying to generate, so that the natural tendency of the model to generate. These models are often trained or fine-tuned on the same kind of very good-looking people. They're always young, they're always in shape. And so if you want to try and adapt them to different people, you need to slightly overfit on them. This is a technique.
Yeah, the other one is, I mean, we actively detect biases, right? So, I mean, the model that we're using has been trained on like 5 billion images. It's really hard to decorrelate the biases, right? One way we actively detect the biases, and then we basically use negative prompt, which is basically like an example for the gray hair would be, put me gray hair without glasses, right? So basically we counteract the bias inherent to the model by explicitly saying, don't do that.
Right.
Yeah,
right.
that's the thing. It's not probably, there's some, it's manual, right? We're not like deleting all the biases, but the one that we detect, we counteract.
And with the growing role of AI in photography, what does this actually mean for human photographers? Do you see this as something that's going to be able to collaborate with and accelerate, or are we all going to start just using AI-generated photos of ourselves?
I mean, for us, right, for the consumer, I think it's a great opportunity to generate high-quality content, being able, without like, expensive gear, without maybe knowledge about too much knowledge about photography. So that's great, right? It makes accessible, it gives you the ability to express yourself and generate high-quality content. For photographer, I think it's going to enhance their creativity process, basically. That's not going to replace their work, of course, their job, but it's going to be an aid to them. It's going to enhance their creativity, and they will find even more ways to be creative.
Yeah,
This is the same that happened from analog to digital.
Yeah.
Yeah.
Yeah, one challenge is that again, with a photography, you generally don't need to generate stuff from scratch. You want to edit something that already exists, and the model kind of has to understand what's in the picture to make something. You want really an assistant. You want like a junior editor that works with you to edit the picture. You just give high-level instructions, and they will make the work for you. This is what you ideally would aim for. And we're not quite there yet.
Right. And I wanted to ask you about some of the risks. So for instance, there might be people who have been resistant to AI photography because they're worried about where their image data is going to go and how it's going to be used. Interested in knowing how you address that, and then also the bigger picture of risks that we might see moving forward.
Well, regarding personal information and personal data, the simplest thing we can do is just not to hold them for long. So whenever it's possible, we essentially delete the data that's needed when we don't need it anymore. So we try and strive to be as privacy-preserving as possible. Regarding more general AI risks, there are worries, of course, because this kind of technology can be used also for malicious uses. It can be used to impersonate other people and do scams. It can be used to generate unwanted porn. It can be used to generate imagery that accompanies fake news. These are all existing risks when you are able to generate images, from scratch. And there is ongoing research to try and address this. This is less it's an issue that we consider, but it's less of an issue for a consumer app as our own, because in general, we do not generate arbitrary content. We stick to presets. So we do not generate malicious stuff kind of by default, because we kind of know what we generate. We're not open for users to choose and generate arbitrary content. This already simplifies life a lot. But of course, these models are available, this kind of techniques and models are available to the general usage outside of our apps, and people can use and do use them to generate malicious content. And there is research to try and mitigate that. Essentially, I can think of like two complementary approaches. One is like blacklisting, so trying to make so that content that is AI generated is detectable by some kind of watermarking. the difficulty here is that the kind of watermarking should be resistant to all kind of post-processing that user might do. So if I generate a fake image representing, say, some riot happening that really did not happen, and I have a watermark in it, that kind of watermark needs to be resistant to everything you might do to the picture. Maybe you can crop it, rotate it, change the color, the contrast, blur it, super resolute it, and you obtain different versions of the same pictures. And if one of these versions loses the watermarking, and so it's not identifiable as AI generated, the usage of the watermark is moot. So there's not many point of having it in the first place. And generating reliable watermarking that resists all these kind of modifications is kind of hard. The other approach is in the other direction. I think it's Reuters that did some stuff in this direction. So they start from, they use cryptographic techniques to ensure that the images they generate are really from them. So they start from a camera that takes pictures and signs them with the identifier of the camera so that you're sure that the picture really comes from that camera. And then the editing software propagates these signatures, and so you can tell, you have a chain of trust. You can tell that the image that you see, say, online on the site has been generated with that camera and then has been edited through this software by these people. And so this gives you a sort of trust that, the image, may be fake. You don't know what these people did during editing, but if you trust Reuters to do reliable reporting, then you can sure that this picture really does come from Reuters and has been edited by them. I'm not sure it was Reuters, but I'm 90% sure. So this is another approach to make sure that we can distinguish what's real and what's not in the wild.
Of course, there could be watermarking techniques. Of course, they have to be resilient to small changes to the picture, etc. I think it's important. I think it will be important to that images will have a clear provenance, right? So what generated, where was the image generated, by which software, and who generated the image, and then that. Basically platform, I think they're already working in this direction, but social media platform, etc., they would only publish images which have a clear provenance. And if someone take that image and change, even making small changes, basically, corrupt the image, then they don't show it, basically. That to me is something that could be done. This is not just about malicious content, this is also about copyrights, for example. So, people take images, they use them without maybe the rights of doing so, and
Yeah. Going back to some of the conversations and keynotes that we heard earlier today, what advances have been made in AI's ability to semantically understand the content of images, including recognizing objects, scenes, and also relationships and emotions within photos?
I think this is something which is crucial also about what I was saying about having a collaborator that helps you edit images. We did some experiments in this regard. We're not quite there yet, but we tried to do something where we could edit a picture by just talking to a software. There's a poster actually about it. And one of the difficulties is, okay, you need the generative part. You need to be able to generate whatever edit the user is asking. But you need to generate it in context, and so you need something that really understands what's in the picture. And we've seen there's a growing body of models that do a pretty simple strategy. They reuse all the knowledge that is inside a large language model, and they make it multimodal by attaching, say, an image encoder before applying the large language model. This is a technique that was born, I think, for image captioning, but it was later extended to visual question answering. So you have an image and you want to be able to ask any question about the image. So what are the people in the image doing? Can you write a short story that describes what happens in the image? And we've seen lots of progress about that. There's an open source model called Lava, which is kind of impressive in this respect. And A few days ago, also a paper from Meta called Animals showed that it can be extended not only to image, multimodality, but also audio and video. And the technique is really simple. It really relies on having robust and large language models that really understand a lot about the world, and the encoders themselves that give these multimodal capabilities are rather simpler to train than the large language model in the first place. This is the same thing that we've seen before with incorporating radar information in large language models, and that you can ask them questions about spatial relationships. The same technique, essentially.
Yeah, the semantic understanding, I think, also comes from seeing a lot of data. If you look, like, for example, at AI photographs, right? What enables the generation of such realistic compositions, right? Which clearly depict an understanding of a semantic understanding of the model, of the words, of the perspective, of the space, of gravity, comes from the fact that it has been trained on billions and billions of images with a captioning, with a description. Another example is GPT, like ChatGPT, for example. It gets better, but it's not, the technology is not like, it's also the underlying model, let's say, that makes it better, but mostly it's the data that sees, right? So it's been trained on more and more data, and that helps a lot to basically ingest this semantic understanding. I think there are some studies, some papers about it. It takes much less data for humans to understand and the semantics. For models, it takes more data, but I think they're working on that too.
Thank you. So I have a couple more questions left, but I wanted to give the audience an opportunity if you have questions that you would like to pose. There's one there in the back.
Hello, Alberto here. Thank you guys for the great work. I just have a question considering hands. I don't know if you've heard the with the generative part of images with hands or other strange artifacts. Did you manage to find some solution to these type of issues, or if you have any grasp of it, or whatever, comment on that? Thank you.
Well, there's not a ready-made solution that works every time. There's a few things you can do. For one thing, models have kind of evolved, so there are many fine-tuned models that are much more realistic about human anatomy and hands in particular. So if you start from those models, you're probably generating more realistic hands in the first place. Then there are detectors. You can simply discard bad images. You can detect how many joints there are, and if there are too many or too few, you figure out that it's not a good image to show to the user, and you just discard it. You can also do restoration techniques. So if you detect that there's some issue, or you suspect that can be some issue, you can do some in-painting just around the problematic area, so that the whole capacity of the model can be fully concentrated on generating a good hand. So you keep the pose, maybe detect the pose of the hand. You're not quite sure that the hand is realistic. You take a crop around the hand and you regenerate just that part, keeping the pose with content or something like that. This is another technique that you can use to make sure to restore hands. Or you can use prompts that generally do not show hands in the first place. So you can try to generate people with the hands in their pockets or whatever. So you can be a little more safe about what you generate. I mean, by combining all of these, you can be 99% sure that you will not generate bad hands, but you never know.
Thank you. Yes, we have one more question here in the front. Do we have a microphone? It's coming. Thanks. And if you don't mind standing up and saying your name, that'd be great. Thank you.
Thank you very much for coming. I'm Andre, and I have actually two questions that I'll try to disguise as one. So a lot of times when we prompt those models to generate photos, specifically if the photos involve text, the text ends up being very distorted, like on the generated images. That's something that I've noticed from using them. The first question is, have you thought of how to address this issue of specifically text getting distorted on a photo? And secondly, do you think that a potential solution to that might be actually multimodal systems? So I guess that now the entire paradigm is end-to-end. So you prompt and you generate image. But maybe a potential solution could be one model for generating the human part, and another model for generating the scene part, and then a third model to combine the two. So was that a potential issue in that you encountered?
Thank you.
Well, about text in particular, it's not an issue we have run into it a lot because the kind of images that we generate tend not to contain text. So this has not been a really big issue so far, unlike hands, say. There are models that are better at text than general models. I've seen also some works that try to explicitly restore text, like they take as input the actual string that you want to put them, and they take a badly generated text and try to generate the actual text that's in the string in the style that's present in the image. And this may be a solution in the optic that you were describing. So you generate a general image with a general model, and then you fix issues with people, with text, and whatever with specific models. So I don't remember the specific paper, because as I mentioned, it's not something we work on a lot, but I remember it was specifically about that. So it was generating text, following the texture and the colors that you were seeing, but actually generating real readable text. And this is a solution. Regarding the second question, yes, in general, I think, as I mentioned, we kind of do already this kind of steps. You do not generate stuff really end-to-end if you want to have high-quality results.
Great. Well, thank you. I'm afraid that's all we have time for, but you will be joining our all-star panel at the end of the day, so we can come back to your questions now, but thank you to our guests.
Thank you very much.
Thank you so much.
Ciao.
Thank you.